Hello class and welcome to lesson 3.4, operations with radicals. Radicals may seem like a new term to you, however we have been using them before, just maybe not expressing them as it. You probably remember radicals as mostly taking the square root of something, but you could also take a square, a cubic, or a higher root. Okay, apologize for that interruption. So radical is basically wherever you see a square root sign. Okay, so to take a square root, it looks like that, or just square root of 15. Okay, and the 2 is implied with that. When you take the third root, there's a cubic root, looks like that, and you could even take the fourth root of different things, or fifth or sixth or seventh. Okay. So when you take a look, ladies and gentlemen, at a radical, you can either take the square of it, the cube of it, or a higher root like we have here. Okay, just take a look. If I have root 41, that is the entire radical. Okay, it's called an entire radical, where if I have 2 and then root 5, that is a mixed radical. All right, so basically we're going to remember our integer laws while we take a look at doing some of these simplifications here. So first of all, to multiply, root a times root b equals the root of ab. Okay, so you multiply those together. They're both under the square root sign, so they become a product under the square root sign. Taking a look at the second example, our second rule that we're going to use is when we have a root b times c root d, that's going to equal ac times root bd. So again, you take the whole numbers out front and multiply them because they're classified as like terms, and then the terms in the square root, ladies and gentlemen, are your equal kind of bases, so they put together because they're both raised to the exponent of 1/2. Just to remember, guys, that if you had x under the square root, that equals x to the 1/2. Okay, likewise, if I have the third root of 8, that equals 8 to the 1/3. That's just a way of expressing either in exponential form or in square root or radical form. All right, let's take a look now at these two multiplication examples. So if we have root 6 times root 3, that's going to equal root 18. Okay, so we're multiplying it through. Taking a look at example B, we notice that we got two whole numbers, so -3 times 2 is 6. Root 7 times 2 is 14. Okay, so we're actually multiplying the the radicals there. All right, number 2, let's learn how to convert mixed to entire radical. Okay, so taking a look at 3, remember 3 here is outside of the square root sign. If we want to put it back in, we'd have to realize that it's 3 squared times root 2. Okay, so that's going to be root 9 times root 2, which would equal root 18. So again, that's changing a mixed radical into an entire radical. All right, let's try the next example here. Okay, so 5 is outside, which means if we put it in the square root, it's got to be 5 squared times root 3. Okay, so it's going to be root 25 times root 3 equals root 75. All right, next one, a little harder here, but we can do this. Okay, so taking a look, folks, first of all, let's do the base, which is the third root of 9. Okay, and when we go to do this one, it's the third root of 4, but instead of squaring it inside the root, I've got to now cube it because it's a cubic one. Okay, so then that's going to be the cubic root of 4 times 4 times 4 is 64 times the cubic root of 9. Okay, when you multiply those together, you're going to have the cubic root of 576. Okay, so again, this initial 3 comes from here, And when you take the whole number in, instead of it just being a square root, which would be the power 2, it's got to now be expressed to the power of 3 when you bring that whole number in under the cubic root. All right. Number 3, we're going to now converting entire to mixed. So what we have to do is look for factors that are perfect squares. This is your most common form, ladies and gentlemen, of radical transformation, okay? So basically, if you have one of those matrix or you know your times tables, on a matrix, ladies and gentlemen, you look at the diagonal. So for example, 1, 4, 9, 16, 49, etc., all the way through. I missed 36 in there, 25. All of those are the numbers we're looking for. So taking a look at 72, the biggest perfect square that goes in there is 36. Okay, and it's 36 times 2. Because 36 times 2 is 72. Then you can break them up into 2 parts. So it's going to be root 36 times root 2, which equals, sorry, my fault, ladies and gentlemen, 6, because that's a complete square, root 2. I just lost my place there. Sorry. Okay. All right, let's try example B. This one might be a little harder. So again, look at your perfect square and see the biggest number that goes into there. Okay, and so you're going to take a look and you know root of 81 goes in there, and it's times root 5 times. Okay, square root of 81 is 9, and then it's 9 root 5. All right, one more and then we'll get a little harder. Okay, so for C, ladies and gentlemen, looking at that, use some time to say what are your perfect squares that go in there. So root 49 and root 3 both go in there. Okay, so square root of 49 is 7, and you have root 3 left over. This one is tricky, ladies and gentlemen, because it's the third root. Okay. So in this case, you're not just looking at that diagonal, you're looking at cubic roots, okay? So 1 times 1 times 1 is 1. That's not going to simplify. 2 times 2 times 2 is 8, so you're looking for 8. 3 times 3 times 3 is 27, and that, in fact, is one that we're going to use here. So the cubic root of 27 times the cubic root of 3. So the third root of 27 is 3. And then we have the third root of 3 left over. All right. Moving on here, I'm just going to extend the page up. Okay. Write in simplest form. So basically, you're converting it to mixed. Okay. So taking a look, we've got root 50. Okay. Again, you should recognize root 25 times root 2. Okay. Which is 5 root 2. All right. Looking at example B, we have 3 out front, so leave that there, and then break this down into root 9 and root 3. So now we have 3 times 3 root 3, which equals 9 root 3. All right, taking a look at the last one, 2 root 80. So it's going to be 2 times, let's go 16 times 5, which gives you 80. Okay, so it's going to be 2 times 4 root 5, which will total to be 8 root 5. All right, here ends the first page. We're just going to do, that's multiplying and changing into simplest forms. And now we're going to take a look at adding and subtracting, and then we're going to multiply with expansion on our second page. And again, please come see me if you need any help. Okay, adding and subtracting radicals, you can only do like radicals. Okay, so what you need to do is to make sure that we know what like radicals are. So for example, root 2 and 3 root 2 are like radicals because they both have root 2. Okay, let's try another one here. Okay, the cubic root of 2 and root 2 are not Okay, be careful here. They both look like they got root 2, but this one has the cubic root of 2, okay, or the third root of 2, okay? So basically what you need to do is take a look at how we do this, all right? So what we're going to do is add the coefficients and leave the radicals the same. Just like when you have, if you just pretend that the root 2 or whatever is an x, okay? It's just like collecting like terms. So the rule is to add the coefficients, okay, and leave the radical the same. Okay, let's take a look here. All right. So just pretend if we had, for example, guys, we had 3x subtract 2x. You would just tell me that that's 1x. Okay, let's transfer it over here to radicals now. So 3 root x subtract 2 root x is just going to be root x, or 1 root x, which equals just root of x. Okay? Next one, if I have 5 root 2 plus 3 root 2, that's going to be 8 root 2. Again, if you need to change it just to help you understand that, just remember back to grade 9 or 10 when you had 5x plus 3x. That's going to equal 8x. Okay? All right, let's try some harder ones now. Okay. Looking at C, do we have the bases the same as they are? No, because they're different radicals. So we need to get the radicals to be what we call like radicals. Okay, so let's break each down. So root 20 can be root 4 times root 5. Okay, plus root 45 can be broke down into root 9 times root 5. The reason we're heading this, folks, is we're going to eventually end up with root 5s. Okay, so let's simplify that. It's going to be 2 root 5 plus 3 root 5. And now we collect what we call like radicals. So that's going to equal 5 root 5. Let's try one more here and see if we can get it. Okay, so looking at this, ladies and gentlemen, currently we have 3 root x subtract 5 times 4 root x. Just remember, though, that when you have root 4x, that equals root 4 times root x. So we can actually bring that out. Okay, let's try that. So it's going to be 3 root x subtract 5 times 2 root x. So again, I'm still keeping it the same value. I'm just realizing that, hey, since root 4 is a perfect square, that becomes 2. Okay? Simplify that a little bit more. So we have 3 root x subtract 10 root x. And then we collect like terms. So 3 subtract 10 is negative 7 root x. All right. Last one, ladies and gentlemen, is expanding and then simplifying. Just like with algebra, we're going to use the distributive law or FOIL. So use distributive law or FOIL, first, outside, inside, last, to expand. All right. Here we go. So let's do that. This first example, whatever is out front of the bracket gets multiplied by everything inside the bracket. So taking a look at that first product, it's going to be 2 as a whole number and then root 15. Okay. Looking at the second product, it's going to be negative 4 root 18. Okay. Then we look to see, is there any way we can simplify these or get like terms? Okay. So 2 root 15, we can't break down any farther because you can't take the root of 5 and you can't take the root of 3 and bring it out into a whole number. But we can simplify our second expression, ladies and gentlemen, because root 18 can break into root 9 times root 2. Okay, let me just fix that up so it looks better. Okay. And I apologize, there should be a subtract sign there. Okay, sorry, I can't erase the video. Sorry, let's keep going. Now we're going to take a look. 2 root 15 stays the same. And now what we're going to have is negative 4 times, you take the square root of 9 out, and you should get negative 12 root 2. Okay, so that's as simplified as it can get. All right, let's try the next example here. We have a binomial times a binomial, which means we're going to be doing FOIL. So we're going to multiply the first with the first. It's going to take some time here. So it's going to be negative 6 root 25. We're going to fix that in a minute. Okay. Our outside is going to be plus 15 root 50. Okay. Taking a look at our inside, ladies and gentlemen, it's going to be negative 4 root 50. And taking a look at our last, we're going to have 10 plus 10 root 100. So although we have 4 terms here, they all look like they can simplify into an easier expression. Before we try to simplify, can you automatically see some like terms here? Usually that's that outside inside that allows us to have like terms. So let's simplify that first. Collect like terms. So 15 subtract 4, it's going to be 11 root 50. Okay, and now we're going to simplify these expressions and break them down. Okay, so we've got negative 6. When you take a look, square root of 25 is 5 plus 11. And then we're going to take that and make it root 25 times root 2. And our last expression, again, it's going to be 10 times 10. So what are we going to have here? We're going to have negative 30 plus, take the root 25 out and makes it 5. So 5 times 11 is 55 root 2 plus 100. And to lastly collect like terms, we have 55 root 2 plus 70. Again, collecting like terms and using your algebra tools that you know with FOIL and distributive law. All right, folks, here's your homework for today. Page 167, numbers 2 to 7, odd only, ACE, etc. That's what I mean by odd only. And the 9, 12, and 13 and 15 are challenging ones, so give them a try. Here ends today's lesson, and have a great day.